In my TikTok live today, AvacadoMath told me about daily integral and he challenged me with this one. Let me show it to you.
It's the integral from 0 to pi over 4 sine x over the square root of 1 minus sine squared x dx.
So looking at this problem, I'm thinking, okay, what am I trying to do? It's a definite integral, so the answer is going to be a number. There's probably going to be some clever u substitution or trick that I can do. And so the first thing I'm going to do is I'm going to rewrite sine squared.
We know that sine squared x plus cosine squared x is equal to 1, which means that sine squared x is 1 minus cosine squared x. This gives us the integral from 0 to pi over 4 sine x divided by the square root of 2 minus cosine squared x dx. That 2 inside the square root is bothering me, so I'm going to factor it out, and I'm going to get sine x over the square root of 2 times the square root of 1 minus 1/2 cosine squared x dx. And now here you see the substitution. U is going to be 1 over root 2 cosine x, which makes du equal to 1 over root 2 negative sine x dx, because the derivative of cosine x is negative sine x. This gives us the integral from x equals 0 to pi over 4. Those are still x bounds. But now after the substitution, we're left with, in the top, a negative square root of 2, and in the bottom, a square root of 2 times the square root of 1 minus u squared du. So how do we change those x bounds into u bounds? Well, remember that u is equal to 1 over root 2 cosine x. So if x starts at 0, u starts at 1 over root 2 times cosine of 0, but that's just 1 over root 2 or root 2 over 2. Similarly, if x ends at pi over 4, u will end at 1 over root 2 times cosine of pi over 4, so we get u ends at 1/2. So our integral becomes the integral from root 2 over 2 up to 1/2 of negative 1 over the square root of 1 minus u squared du. But because of that negative sign, we can actually switch the order of integration, and we get the integral from 1/2 to root 2 over 2, 1 over the square root of 1 minus u squared du, and that integral is just arcsine of u evaluated from 1/2 to root 2 over 2. Since arcsine of root 2 over 2 is pi over 4, and arcsine of 1/2 is pi over 6, we get pi over 4 minus pi over 6, which is exactly pi over 12.
So that's the answer. The answer is pi over 12. That's so cool. Thanks, AvacadoMath, for the question. This came from dailyintegral.com. So why don't you guys check it out, see if you like it.